will you be able to solve this? Rishita, will you be able to solve all this?
Yes, sir. So for the 33rd one, is it B?
So 33rd is basically your which one of the following pairs represent a stereoisomerism, structural isomers and geometrical isomerism, which is wrong. Yeah, 33, it's B. Wait a minute. Chain isomerism and rotational isomerism. Which one of the following represents? Yes, it is B. What about the 32? Which one of the following given compounds can exhibit tautomerism? So you need to find this. This is your main functional group. So, okay, okay. So basically it will be one, two, three, four, five. Six. Okay, just wait a minute. Hmm. Okay, all of it will show because here, after this double bond, the pi bond is in conjugation. You can see pi, sigma, and then this is your sp3 hydrogen. So all of it, basically, you can see pi, sigma, and then sp3 hybridized carbon, which has a hydrogen, sigma, pi. You can think like this. So the answer will be C for 32. All of it is going to show tautomerism. Tautomerism, have you studied? Yes or no?
Yes, sir.
No.
So are the 34, is it resonating structures?
34 is,
A.
oh, wait a minute. This is this. Okay, so what we can do like this and this. Yes, A is the resonating structure. See, in tautomerism, atoms also moves like alpha hydrogen. From here, hydrogen we are going to move to this side. But in resonance, only pi electron moves. So electron moves to this side. So that is correct answer. 35 tautomerism will be exhibited by, yes, this one. Because there is no alpha hydrogen, there is no alpha hydrogen, there is no alpha hydrogen. So D is the correct answer. Very good. For this, the answer is B. 37 is very easy. Rishita,
Yes, I know. I was just writing the question.
hmm,
It'll have the same function structural formula, right?
no,
Mole.
molecular formula. Isomers are having same molecular formula, different structural formula. Due to this different structural formula, they will have different physical properties.
Okay.
Hmm. How many chain isomers could be obtained from the alkane? This is also very easy.
5, right? So
What did you say?
5 B.
Yeah. Increase your speed as well. The accuracy is good. Go for this.
So for 39, it's C, right?
Yeah, because you need to draw the tertiary butyl chloride, butyl carbocation. So it is 3-degree carbocation. If you are going to say this will be like this, and then they say secondary butyl. Hmm, just wait. No, it won't be. This becomes iso. Okay. So secondary, how we can draw? Do it. CH plus is there. CH3 is there. CH2, CH3 is there. This becomes secondary. So 3-degree, you can see there is no R effect. So this will not be the answer. This will also not be the answer. And the alkyl group is minus I. Simple 9 alpha hydrogen and 5 alpha hydrogen. This is a practical based qualitative and quantitative analysis in which if you are going to see paper chromatography is an example. This is an example of partition chromatography. If you will perform the experiment, you will get it. Next are very easy.
So B, 41B.
Okay, so if you are going to see this is your 1 degree, this is your 2 degree, everyone is 2 degree, and but here it is like this one. So yes, it is B. Wait a minute. Hmm. No, this won't be the answer. If you're getting this type of basically inductive effect, if you are going to see, so B will be the answer. But if there is three things in effect in this chapter: inductive effect, hyperconjugation, resonance. And we are going to give preference to resonance first, then hyperconjugation, then inductive effect. So we are going to think about the inductive effect and hyperconjugation. Both are possible here. So here you get 2 alpha hydrogen. Here you get 3 alpha hydrogen. Here you will get 2 plus 2, 4 alpha hydrogen. And here you will get 2 plus 3, 5 alpha hydrogen. So which one will be the most stable? The stability directly proportional to alpha hydrogen. So D will be the most stable, right? Yes or no?
Yes, sir.
Yeah. So you have to check every possibility.
Is it B this time, sir?
42 is the question among the following the
42.
reaction that proceeds to an electrophilic substitution. That means electrophile will attack first. So here you are going to see Cl2 in the presence of AlCl3. Cl2 will be going to go like this, negative, and there will be positive. So basically this is your halogenation reaction. So B is the answer. In all of this, this is your addition reaction. This is your nucleophilic, you can call it. So B is the correct answer. Got it?
Yes, sir. So can you explain the uh, for 43rd question?
Okay, very simple. This is see. This is positive, that means electron deficient, and this is electron withdrawing group, right? So this is having electron deficient. It requires electron. That means it should be away from the group which is having the nature of electron withdrawing group because it is already having a deficiency of electron. So that means NO2 should be away from this, far away from this. So this cannot be the answer. This cannot be the answer, right? Are you getting my point? This positive carbon shows that it is having deficiency of electron, and this carbon is connected with NO2, which has a nature of electron withdrawing group. NO2 has a very powerful nature of electron withdrawing group. Are you getting my point?
Yes, sir.
Now this and this is cancelled because NO2 is just connected to that. Now out of this A and B, in which it is away from it. NO2 is 2 away from it. That is your D, right?
Yes, sir.
Yeah, in all of this compound, you will see that resonance is taking place. That is another thing. But in all of this, resonance is taking place like this, like this. Cross conjugation is there, like this, like this. But positive charge should be away from this because it has deficiency of electron and it should be away from the electron withdrawing group. That's why. So the answer is D. Okay.
Yes, sir.
44. Which of the following is correct with respect to minus I effect of substituent fluorine? This. You have in your class have got the series of minus I effect and plus I effect. Please go through that. Very important. That is. Questions are will be direct on that. Fluorine is the first most electronegative element, then oxygen, then nitrogen. So the answer is here. 45 is also very easy. Ortho and paranitrophenol. Orthonitrophenol, phenol you are going to draw, and ortho that means NO2 will be at this position, and paranitrophenol that means this is the scenario. So you know this will be separated if they are going to be mixed in 1:1 ratio. That is your steam distillation, because their boiling point difference will be very lesser. So we use not distillation but a steam distillation. Okay, is that clear? Can I change the slide?
Yes, sir.
So your exams will be starting in which month and date? Have you got the date sheet?
So for 46 is C, right?
Yes, it is. Yeah, it can be neutral and positive charge. It cannot be negative or lone pair.
Sir, is this SP high SP just D?
Yes, SP. This we need to calculate and sigma 1 plus lone pair, negative charge lone pair. So 1 plus 1, 2. So the answer is D.
Nucleophiles are not electron seeking D.
Very good. Wait a minute. Which of the following statement is not correct for a nucleophile? Nucleophile is a Lewis acid. Ammonia is a nucleophile. This is wrong. Wait a minute. Ammonia is a nucleophile. Okay, that is correct, right? D is correct because ammonia
Yes.
gives electron, right? But nucleophile is a Lewis acid. Lewis acid means electron acceptor, and nucleophile, what does it do? It donates electron, right? Rishita.
Yes, sir.
So the incorrect is A, right? Incorrect is A.
Oh, okay. So D is right.
A is incorrect. Nucleophiles are not electron seeking. This is also correct, no? Nucleophile is already having lots of electron rich nucleophiles. So why it will seek electron? Are you getting my point?
Yes, sir.
Okay.
So, is the second one 50th one B? I don't know for sure.
Okay, 50th. Which of the following is the most correct electron displacement for a nucleophilic reaction? Okay, nucleophilic, this will be gone. Very good. After that, okay, this cannot be go there because there is deficiency of electron. So this is wrong, right? Because this is going, so there will be deficiency of electrons. So this should come on this side. So B is the correct answer. And this cannot go directly here. It has to be moved here. That's why it is wrong. If this is going to this side, so this cannot support from this side. So B is the correct answer. 49.
49. I didn't
Okay,
get
see,
it right.
hyperconjugation occurs in this is your, what do we say? This is your free radical system. So there must be alpha hydrogen. This is your alpha carbon. This is your alpha carbon. But this alpha carbon doesn't have alpha hydrogen. No alpha hydrogen. So it won't show hyperconjugation. If you are going for this is your system. So carbon, 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 benzene. Every carbon is not containing any alpha hydrogen. So this is also not the showing hyperconjugation. But with the help of this, you can see carbon is there, which has one alpha hydrogen, and this is also having one alpha hydrogen, but we cannot remove this because it is bridgehead. So only three. So the answer will be B. Is that clear?
Yes, sir.
No. Moving to the next one. Please. This 51 is and 52 is completely formula based. If you know the formula, you can do this. Otherwise, you won't be able to do it. Any answer?
So it's 17.3736.
No, there is slightly mistake in question number 51. Basically, when you will get option like this, you have to be more careful when you are going to do the calculation. And the answer is basically 16.76. Okay, so I'm gonna show you. Very simple this is. In Dumas method for estimation, of an organic compound, you can say 0.25 gram is given. That means weight of organic compound OC is equal to 0.25 gram. Okay. After this, just wait. Give 40 ml of nitrogen collected at, okay. The rest is, you can see volume 1 is 40 ml of nitrogen collected at 300 Kelvin. T1 is 300 Kelvin and temperature and 725. P1 is also given. That is 725 mm pressure. If aqueous tension is given, so we are going to subtract this aqueous tension and you will get P1 as 700 mmHg. This is how you are going to get it. After that, P2 is, we can take atmospheric pressure, that is 760 mmHg. Okay, and T2, since we are considering this at STP, so T2 will be 273 Kelvin. After this, we can directly apply this formula. P1 V1 is upon T1 is equal to combined gas equation P2 V2 upon T2. And from here, V2 we can easily calculate. For V2, you know that what is going to be happen V1 P1 P1 V1 into T2 upon P2 T2 T1 P2 T1. And after substituting all the value, P1 you can see it is 700, right? And T2 that is equal to 273 and T2, sorry, V1 40 upon P2. P2 is what? 760 and T1 is what? 3. So after solving this, you will be able to get 33.52 ml. And percentage of nitrogen. In order to calculate percentage of nitrogen, this is the formula. 28 into volume of N2 at STP. Volume of N2 at STP. And into 100 divided by 22,400 into weight of organic compounds. Organic compound or organic substance. And after substituting the value, 28 into volume that we just calculated, 33.52 into 100 divided by 22,400 into 0.25. So you can easily cancel this two zeros with this two zeros and multiply, divide it, you will be able to get this. Got it?
Yes, sir.
If you remember the formula, you can easily do it. Any answer?
37.33.
Yeah. Very, very good.
So D, 53 is D.
Okay, so this is 9 alpha hydrogen, right? And this is 6 alpha hydrogen. This is 3 alpha hydrogen, and this is having 2 alpha hydrogen. So the most stable is B, then comes your C, then comes your D, then comes your A, and then comes your E because it has 0 alpha hydrogen, right? So B, oh, wait a minute. After B, it should be C. After C, it is D. Just wait a minute. On which base you calculated this? This is having 9 alpha hydrogen, that is correct. This is having 6
And
alpha hydrogen.
this one, the A is usually very stable, butane, right?
A. Why A is okay, just wait a minute. 3 plus 3, 6 plus 2, 8 alpha hydrogens. Okay. So are you getting this 8 alpha hydrogen? Yes or no? Hyperconjugation, Rishita.
Yes, sir.
So after B 9 alpha hydrogen, more alpha hydrogen, more stability. B, then A, then comes your C 6 alpha hydrogen, then comes your D 3 alpha hydrogen, and E at last. So the answer is B. Did you say B?
Yeah, I said B.
Okay, I thought it's D. Okay, that's correct. Do this. Any answer?
Um, 1 second, sir. So is it C or D?
C or D? 54 is,
I'm not sure, but I think it's C.
yeah, it is C, because you can see in this you can calculate alpha hydrogen. For hyperconjugation, you have carbocation, you have this, and you have double bond, and you have benzene as a system. So this is as a system, you can see this is your alpha carbon, alpha carbon. So sorry, I mixed that. Okay, see, this is your system. So here you, so this is your system. So here you got three alpha hydrogen. This is your system. So six alpha hydrogen. Here is your system. So two alpha hydrogen and eight alpha hydrogen. And here your nine alpha hydrogen. So it is the most stable. Okay. 55. What is the answer?
SP2.
Yeah, it is. In the next class, which chapter we are going to do states of matter, right?
Okay, sir.
So can you cover this chapter in this week so that we'll be able to do every type of question of every topic?
Yes, sir, I'll try.
Okay. So thank you. I'll see you in the next class.
Thank you, sir. Bye, sir.